Listo.
Hi, good afternoon. We're going to talk about mechanical performance of masonry bricks produced with crushed glass and melted PET plastics. I'm Simon Carvajal, and my companion is Pablo Maigual. Here's what we're going to talk about, the index. As you can see, we are going to summarize, starting with the with the study that was made around 2020 and 2021 and analyzes the production of masonry bricks using PET plastic waste and recycled crushed glass. This works by incorporating varying RCG radius, and the produced WMB go through compression and tensile strength tests. Performance improvement of 70 and 54% respectively were shown in comparison to traditional clay bricks. Durability tests, including exposure to acid and sodium sulfate solution, revealed WMB success as it has no mass loss due to the hydrophobic characteristics in PPW and RCG, while clay bricks show a 12% loss in its test. WMB also follows the South African National Standard of or ASNS 227 for load-bearing structure, making it a multifunctional tool in various constructional applications. These are the keywords. And starting with the material acquisition, we can say that this material was acquired in the Marine Hill landfill site in Durban, South Africa, following strict healthcare protocols made during COVID-19. After the collection, material go through a series of preparatory steps before the brick production. The PPW is mainly composed of polyethylene terephthalate containing a structural composition of carbon, hydrogen, and oxygen, making it propitious for recycling into construction materials. Now, laboratory preparation of PPW and RCG also involve washing, sanitizing, and drying to ensure safety and consistency with a density determined according to ASTM standards. The particle size in the RCG was chosen to explore how the aggregate size may impact the comprehensive and tensile strength and the structural behavior of the bricks.
Composite preparation. The composite preparation of the WMB involved a series of blending and molding steps to create bricks of variable ratios of RCG to PPW. The plastic was heated up the temperature to 220 degrees centigrade, and later the composite is stirred of a homogeneous mixture. The mixture is poured in bricks mold coated with silicone base, releasing spray with facility easy removal after cooling. Unlike conventional clay bricks, with a require significantly amounts water and energy during the production. The WMB production process use not water.
Now, for testing procedures, we saw that in the test they made various tests, uh, including comprehensive tests evaluating mechanical composition properties, durability, and overall performance of the MBA in comparison to the clay bricks.
Okay, and the testing produced unconvenient compressive test. The test material load bring capacity is well made following the ACTM D2166. The VM seems called to 2 days post-production were subject to decline compressive loads at displacement radius of 0.0 millimeters per minute. When the maximum load reaches, the data was taken and the state of the RCG in megapascal was defined by the bricks cross-section area. The results revealed the WMB had a better performance than traditional bricks.
So now for splitting tensile strength, we can see in WMB samples were placed horizontally in a tensile machine with a steel in the plate, and then distributing the pressure evenly across the whole length of each brick. The maximum load was tested, and it showed that WMB had an approximate 4 times less that is compressive test, but in terms of clay bricks, it showed that it has 8 times less in compressive strength. This means that WMB has a best resistance to tensile strength and is less probable to crack in comparison to clay bricks.
Okay, the ability test consists of subject the WMB to different cycles, the wetting and drying in a sodium sulfate solution, imitating the effects on saline and wet moist environments. With the clay bricks, present a 12% reduction in the mass and the structural degradation among cycles. The WMB present minimal change in the structure. Test results show WMB maintained structural integrity across all acid concentration, with the clay bricks were significantly compromised, showing declaration due to the acid infiltration in this pore and loss in its straight.
So now we're going to analyze the results, starting with the unconfined compressive strength. As you can see in the graph at the left of me, WMB has a average value of 35 MPa, and the clay bricks show an average value of 14 MPa. This shows that the that the compressive strength in the WMBs is higher, and due to this durability, and as to the densities presented, the low porosity caused by the RCG are directly implied with the stiffness of the material, and it's also related to its strength. Now, for effects on wetting drying cycles in compressive strength, we can see in these graphs A, B, and C. WMB2 has the highest QU, that is for compressive strength, being 43 MPa. WMB3 has a following IQU of 38 MPa, and WMB1 33 MPa. All of those maintaining its compression strength. In contrast to fire clay bricks, who show in all three tests significant less values for compressive strength past the cycles, with an average of 14 MPa and a mass loss of 12% during the cycle. Now, for the wetting cycles in split tensile strength, or QT, sorry, results as shown in the graphs, we can see that WMB2 also achieved the highest QT values, showing a major resistance in comparison to other WMB values that are also superior in resistance that the clay brick values, showing a notable reduction in resistance strength due to porosity changes and mass loss caused by the water absorption and salt infiltration in the spores.
Okay, and this is the performance of WMB and clay bricks subject to different acid immersions. The test effect of acid concentration on the tensile and compressive straits of the bricks is analyzed. Internal hydratation of calcium silicate and hydratation of calcium aluminate lost their stability and accelerate their hydrolysis, destroying in the internal structure of the clay bricks, result in low compressive stress. The results highlight the superior acid resistance of the WMBs, making it sustainable for construction in environment with tendencies to present acid export, such a pollutant in the industrial area. Okay, correlation of compressive stress with tensile test on brakes. The correlation, the correlation with tensile and unconfined compressive stress of clay and WM brakes are present. And the correlation in WMB is attributed to the viscoelastic properties of the PET plastic with distribute tensile and the compressive stress more uniformity. The result describes a balanced performance in WMB's mechanical properties, making them more reliable for use in flexing applications. And low deformation relationships and failure modes. The failure modes, the representative low deformation relationships of the WMB and Clay bricks under compressive stress are present in the WM bricks under compressive exhibit considered stiffness relation of the percentage of added metal plastic at axial straight. The data with the data of the graphic, these results confirm the WMB possesses a superior low deformation characteristics, including highlight stiffness, durability, ductility, and resistance to failure.
So now, as to sustainability and environment, we can see how the study highlights the sustainability in WMBs as an eco-friendly alternative to traditional clay bricks. As you can see in the graph in columns price, energy, and sustainability, production eliminates water needs and significantly reduces energy consumption by hitting temperatures of only 220 degrees compared to 1300 Celsius degrees needed for the fire clay. This WMB lower cost in CO2 footprint and reduces cost is estimated to be 15 times cheaper than clay bricks if we take into account energy expenses. By using PPW and RCG, the WMB production conserves natural resources such as water and soil, which are heavily exploited nowadays during clay bricks manufacturing. These studies show how WMB is a green effective construction alternative that aligns with global sustainability goals.
Okay, in conclusion, as to mechanical performance, the production process for WMB offers significantly environmental and economic benefits. Overall, PET plastic and recycled crucible glass-based bricks are significantly more effective in most, if not all, mechanical properties compared to the traditional bricks.
Now, this study proves the viability and advantages of using PET plastic waste and recycled crushed glass in production of the WMBs as a sustainable alternative for clay bricks. In comprehensive tests, WMBs range from 33 to 43 MPa, significantly exceeds the one of the traditional clay bricks, that is 14 MPa. This improvement can be attributed to the hydrophobic and elastic properties in PET and the strong bond with the RCG, which reduce porosity and enhance low bearing capacity. Finally, for the durability test, established the WMB's resilience under severe conditions. In wetting drying cycles with sodium sulfate solutions, WMB retained its mass and structural integrity, unlike clay bricks, who lost about 12% of its mass. So that's all. Thank you so much.
Very much.